Hey, in this video, I would like to talk about a common mistake that was repeated by so many people in the LCMS lab report. You were supposed to calculate the imidazole concentration in an extract, and of course, for that, you inserted a linear graph like that, uh, which is called as calibration curve, as you know. This is your data set, a demonstrative or example data set. Here in the J column, we have the imidazole concentration values, and in the K column, we have response values, which were calculated by taking the ratio of quantifier peak area to the internal standard peak area. And then you selected these, and then you inserted a linear graph, a scatter graph, into this data set, and an equation is given to you, of course. You inserted a trend line, and a trend line equation is given to you by Microsoft Excel. And not all of you, but many of you use this slope value, 0.0002, to calculate the imidazole concentration in the extract. However, this is a rounded number. There are not enough significant figures in this equation, so it's an oversimplification. You have to use the LINEST function in Microsoft Excel to calculate the slope value with satisfactory amount of significant figures. Okay, do not use the 0.0002 slope, which is given by the trend line equation. Let's insert a LINEST analysis into this data set, and let's calculate the slope with multiple significant figures. So I will go to a cell, and I will say enter, and then I will say LINEST. Then I should select the known y values, which will be our response values, and then I say semicolon, and then I choose the x values. Okay, and then I insert another semicolon, and then I should say true, another semicolon, and then I say true again, and then I close the parentheses, and I guess I should say Control Shift Enter, and it gives me the slope value. But this is an array function, so it has multiple outputs. You should select 2 columns and 5 rows like that, and then you should go to the main bar, and then you should say Control Shift Enter, and it will give you all the parameters that can be produced by this linear regression analysis. And these numbers are standing for these entities. That one is slope, that one is intercept. This is the standard error in slope, this is the standard error in intercept, this is the R-square value, this is the standard error in the predicted y values, this is the f value, degrees of freedom, some square summed regression error, and some squared residual error. These are the numbers that are created. Of course, you need these two only, slope and intercept. So instead of this oversimplified 0.002 is your slope, take this one to calculate the imidazole concentration in the extract. Intercept was okay, 0.0021, but you may want to go with this one, 0.002097. That was a mistake, again, repeated by multiple people. If you haven't done this mistake, if you haven't made this mistake, just do not take this video into consideration.